Hello, this is part 4 in a little mini series I'm doing on understanding a formula in Veritasium's video on the 100 prisoner riddle. And in there, he makes a statement that each prisoner has a 50-50 chance of finding their number. And so that's what we're going to investigate, why each prisoner has a 50% chance of finding their number. Now, if you haven't watched the video, it's an absolute must-watch video, and I would recommend you watch parts 1 and 2 of this little mini series. Now, if you don't know about the loop strategy, which is an amazing strategy, by the way, you think a prisoner opens up 50 of the 100 boxes to see if they can find their number, and if they do, that's a success. And no one questions that, oh, I opened 50 boxes out of the 100, therefore I have a 50% chance of finding my number, right? That seems really straightforward. But when you start thinking the loop strategy in this video, you think, well, wait, how does he still have a 50% chance? Why is it that? It seems counterintuitive once your mind goes down what I'm calling the loop strategy. Okay, and so that's what we're going to investigate using the loop strategy. Why is it still a 50% chance of finding your number? Now, the critical point is that nothing is known about the boxes and slips of paper within. So boxes are numbered from 1 to 100, slips of paper are numbered 1 to 100 and then randomly placed in the boxes. And then the prisoner uses the loop strategy. They go to the box with their number on it, open it up, and the next box they open is determined by the number they found in the box. And they repeat this until they find their number. Now, here's a little bit of intuition behind what I'm getting ready to say in the formulas, but I think it's, let's develop it. So let K equal the maximum loop size. So in the video, Veritasium video, he talks about loops, and there's different sizes of loops. Of course, the maximum loop size would be 100, where they're all sort of daisy chained together and you come back to the original box. You can have a loop size of 1, and that's where your number is in the box with that number. Now, the random variable x is that we pick a loop of size less than or equal to 50, which means, i.e., we find our number. You find your number. So if you get in a loop of 50 or less, then you're guaranteed to find your number. Okay, and we want to find the probability that we find a loop of less than or equal to 50, right? And I'm saying that is 50%. Okay, now let's look at some little arguments here. The probability of x given k is less than or equal to 50, well, that's 1 or 100%, because every loop is less than or equal to 50. So when we go to our box, we're guaranteed that the loop is less than or equal to 50. So we find our number. So that's 100%. Now, if we're given that the loop is 51 or more, then the probability that we pick a loop of size 50 depends upon k. So let's say if k is 51, that means the other 49 boxes, if our number is in one of the 49 boxes over there, then we could get in a loop that's less than 50 and we'd find our number. So there's still a chance of it happening. And the probability is this, it's 100 minus k over 100. So if there's if the maximum loop size is 75, that means that there are 100 minus 75, so there's 25 boxes it would potentially have our number. So it's 25 over 100. And another way to write this is 1 minus k over 100. Now, if n equals, here's a little quick example. If n equals 100, k is 97. These are the possible orders of the loops, you know, the orderings. We could have a loop of 97 and a loop of 3, and that makes up all 100 boxes. Or we could have a loop of 9, 2, and 1, or, I mean, ooh, that should be a 97. And then, or a 97, 1, and 1. Right? Those are the only three possibilities when K is 97. And then the probability that we find our number is that it has to be in one of these smaller loops, right? So the probability that we find our loop, given K is 97, is 3 out of 100. Now, if, again, not sure why I have this again, but the probability, if the largest loop is 25, the probability we find our number is 1, you know, or 100%. And this is a reminder that when K is greater than 50, the probability of any loop size K is 1 over K. And this was determined in Veritasium's video right here. So let's look at this. So now we simply want the unconditional probability that we find our number in the boxes, okay? So a common strategy is to introduce another variable, but sum it out. And then this is equal to the original unconditional probability of X. Then you can write it as a conditional probability. And then let's break this at 50. So let's sum it from 1 to 50, and then 51 to 100. And the reason we do that, when the maximum loop size is 50 or below, this is 100%, right? So this comes down to here. And here, the probability of K, we just keep it the same, but given K, probability that we find our loop is what we set up here, is 1 minus K over 100. Now we take this into the 1 and then take it into here and rewrite them. So this comes down, that piece comes down, and that piece goes here. Now, this, we can combine this, the probability that we get a loop K, and we sum it from K equals 1 to 100. So that's 100%. And like, we're going to get one of those loop sizes. So this probability is 1. Now this, the K's cancel. We're left with 1 over 100. And we're summing it from 51 to 100, which is 50 of these, so the number is 50 over 100, which is 1/2. So 1 minus 1/2 is 1/2. And so that's why the probability that a prisoner finds their number is still 1/2, even if they're using the loop strategy. Okay, well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.